Hello everybody. Let's solve this problem that came from a 1995 exam that has us dealing with Taylor polynomials. So, first things first, let's read this question. Let f be a function that has derivatives of all orders for all real numbers. So that means that we can have derivatives and then we can have an nth term statement that has this infinite series, right? Also, we need to assume that f of 1 is equal to 3, f prime of 1 is equal to negative 2, f double prime of 1 is equal to 2, f prime of 1 is equal to negative 2, and then the third derivative evaluated at 1 is equal to 4. So let's solve this A. Write a second degree Taylor polynomial for f about x equals 1. So we could already see that we're dealing with a Taylor polynomial that centers 1 at center 1. So when we're doing our Taylor polynomials, we could do x minus c, so it's x minus 1, right, times whatever power n we're dealing with when we are writing out our statement. So, and then use it to approximate f of 0.7. Okay. So first off, we need to do the first one. So we have 3 over 0 factorial times x minus 1 to the 0. Okay, and then we have plus negative 2 over 1 factorial times x minus 1 times, or to the power of 1, plus 2 over 2 factorial times x minus 1 to the power of 2. This is what this general Taylor series looks like for when we have to deal with the second degree. So let's simplify this. So we have a function t2 of x, and then first of all, we must know that 0 factorial is recursively defined as 1, given it's 1 factorial. And so this is 3 over 1 times x minus 1 to the power of 0, which is just simply 1. So our first term is simply 3. And then next off, we have negative 2 over 1 factorial, which simplifies to negative 2 times x minus 1. And then we have plus 2 over 2 factorial times x minus 1 to the power of 2. So this is simply 2 over 2 times 1, so that 2 cancels out and we have 1 over 1, so this is all canceled out. And then, so we could just say it's plus minus x minus 1 to the power of 2. Okay, so let's erase this part and move the equation. I know you guys like me moving these equations, so yep. If I can move it, that'd be nice. And then so we're trying to approximate f of 0.7. So we have let me get the pen out. F of 0.7 is approximately our Taylor polynomial, or second degree Taylor polynomial evaluated at 0.7. So this is equal to 3 minus 2 times 0.7. Vete a la verga, cabrón. Te voy a matar. Okay, sorry about that. Plus 0.7 minus 1 squared. And then when this is evaluated in your calculator, you will get that this is equal to 3.69. Okay, so we have our answer right here. And let's simply move this again. I know you guys are going to be raving about this in the comments section. So let me move this. And let me actually do another thing as well. Since this won't necessarily fit, I just need to resize it. And then it'll fit perfectly fine. Okay. And then now what we are doing is we are writing a third degree Taylor polynomial. for f about x minus x equals 1 and use it to approximate f of 1.2. So to do this, let's just reuse what we've had so far from our second degree Taylor polynomial and just add that final term. So we'll have 3 minus 2 over, or 2 times x minus 1 to the power of 1 plus x minus 1 squared. Okay, and then now we need to deal with the third derivative, which is 4, plus 4 over 3 factorial times x minus 1 to the power of 3. And then so this simplified leaves us with 4 over 6 times x minus 1 to the third. So let me erase this right here and just replace it with the simplified version. 4 over 6. Well, I could technically simplify that fraction, but that doesn't really matter. That'd just be 2 over 3. So f of, we are looking at 1.2. Yep. For 1.2 is approximately the same as our Taylor polynomial evaluated at 1.2, which is 3 minus 2 times 1.2 minus 1 plus 1.2 minus 1 squared plus 4 over 6 times 1.2 minus 1 cubed. Okay, now if you put this in your calculator, this will leave you with the answer of 2.645. Okay, let's do some more resizing. Sorry, this is actually going to be quite a bit of resizing due to the way I wrote this. And so we have this, and then we'll move it right there. Then that will give us our little answer. Okay. And then now let's solve C, the final part of this question. So write a second degree polynomial for f prime, the derivative of x equals 1, and use it to approximate f prime of 1.2. So this is actually a really good one, because this sees us using our third degree Taylor polynomial, right? And finding, because if we have the third degree Taylor polynomial and then we have the derivative of it, t prime of 3, we'll essentially have a degree of 2, right? Because that degree will be knocked off. So let's use our t3. Hopefully y'all can see this up here. I'm going to be using this to reference. So t prime of 3 is equal to, this cancels out. So then from there we have minus 2x, so take the derivative of minus 2 times x minus 1. So the derivative of this is just negative 2. And then we have plus 2 times x minus 1. This is a simple chain rule, so that power stays the same and it's times 1, but I'm not really going to write that. And then we have the derivative of this last term, and then that will be 2 over 3 times 3, so that will leave us with 2 at the front. This is plus 2 x minus 1 to the power of 2. And then f prime of 1.2 is approximately our t prime 3 of x, or evaluated at 1.2, which is equal to negative 2 plus 2 times 1.2 minus 1 plus 2 times 1.2 minus 1 squared. And then if you put this in your calculator, you'll find that this is negative 1.52. Okay guys, I hope you enjoyed this video. I'm going to try to be making these longer videos because I understand that these FRQ questions, especially regarding Unit 10, could be a little bit tricky, especially when the questions in Unit 10 that are multiple choice are sort of straightforward at times. But yeah, So thank you for watching. Let me know if you have any questions, and I'll be more than happy to answer them.